Number one, we can just do over here. I'm going to remove as we move forward. So the first one, we are checking for null. If patient is null, then return null. This one is simple, of course. Then preferred name if the patient has one, otherwise the first name will be fetched. So this one is done, and we are going to be fetching all the patient names. So we do have patient. From the patient object we are going to get person, and from this person get names, right? And we are going to iterate all of these. Like, let's use some lambda expressions. Dot stream, and we'll filter, and filter for person name. There's a property dot preferred, get preferred. If there is one, then find first. OpenMS doesn't allow multiple person names as preferred. Let me actually show you what this means in the data. Patient may have multiple name sets registered against him. The preferred one is the current one, the active one, which is chosen on the UI. So there's only going to be one latest preferred one. There can't be multiples. What we are saying here is, if there is a patient a preferred name, then return that. If there isn't one, then or else we are going to get first name. Wow, just did the read my mind. So patient get person get names or stream dot first object. Even if there is no first object, then return null, which is, of course, it does make sense. There shouldn't be what's the same. Optional is ignored. Yeah, that's fine. I don't need I'm just going to say patient name person name is equals to this, and this will be set into the summary object, but we'll come to that later. We have fetched the person name, and now for the identifiers. Again, it's identifiers is easy. You can just simply get patient identifiers, convert it into a list, so that's not really a problem. Okay. List of patient identifier person patient dot get identifiers. So it's a okay. Let's make it a set, and well, why? Okay, this is going to be a set, not a list. Yeah. This is going to be a set. Okay, we have patient identifiers. And then we have patient programs. So for patient programs, I need context.get. So this is program workflow service, which gives you patient programs, and there's going to be a method called get patient programs, and inside it we have plenty of parameters. So we are only going to pass on patient parameter and then keep everything as null. Patient, no program, null, enrollment, null, max, null, and include voided. No, we only need the non-voided ones. Okay, this is going to return me a list of patient programs. Now I have list patient programs with B. I next need observations, but I don't know which observations of from this patient are going to be required, so I'm going to fetch all of them first of all. So we are gonna say context.getObsService.getObs by observations by person. So person is what? You can just simply pass patient, because thanks to inheritance, and so we have observations, right? Let's call it all obs. We have observations. Now we also need all lab tests. So for lab tests, we are going to say list lab test all lab tests equals to, this is going to be fetched from get service. This is an internal service. We are going to fetch this service by class, and that class is in our module which is providing all the lab tests, lab services, is called lab test service. All lab functions are going to be found over here. So we are going to pass on lab test service, which is going to provide me a method to get lab tests. However, this is an important point to be noted. We don't need entire set of all lab tests against this patient. We are interested in the lab test that is relevant right now. So there are let me actually show you what I mean by that in the OpenMS data. We have this row number 5, a common test. Now this common test contains observations. This is actually converted from the older module, and this contains results for all kinds of MDR-DB tests. You can see the rest of them, they are all merged with this one single type of test called MDR-DB. This is a short name, and the longer one is common test. So irrespective of what test you are doing, all of them are represented over here. The reason is because in the Tajikistan's program, these tests are not considered as mutually exclusive. So you can order one test and have one order and have multiple tests done under its umbrella. So that's how it works, which is why we have one common test. But anyway, our module does provide this feature. Actually, let me just fetch that one. Contest and get service lab test service dot class and get common test type. This is one exclusive test type for us, and we need all the tests that are associated with this type. And this is very context dependent. That's one of the main reasons why I strongly recommend it not to get any help from the AI, or at least if you do, it has to be a really good model for the model development, so that it contains all the context that's required. So we are going to need there's a patient and lab test type, this one. So we are going to pass patient and common lab test type. Let's double check. We are calling this one get all lab tests by the patient and by the lab test type. Okay, all right. So we have fetched the observations, we have fetched the lab test types. Next, in case this is null, we might not want to return a null. Let's just, if let's just be very sure. And now begins the real fun. What we want to return is a list, a patient summary object, and inside patient summary object we have patient program summaries and all of this information. So let's first go ahead and create at the very end patient summary object. Patient summary goes to new patient summary, and patient person name, we have patient identifiers, and then we have patient, or why don't we have it program summaries? Okay, we haven't created this object here. Just go ahead and create one, and this is what we are going to be returning, patient summary. So that's what I need, and it's going to be a list of patient program summaries your list. That's what we are going to return. I think it's going to say inline variable, just return as is. That's fine. Okay, let's move a bit more and get into the final phase of this highly challenging method we are writing. So for every patient program we need certain information. We need the start date, we need an end date, when the case was closed. We need certain observations, right? And all those observations which are part of that program, and we sort of have a loose way of identifying those observations, and I'm going to just shortly talk about that. There are multiple ways, but I'll just implement one of them. Let's now iterate for patient program in all patient programs. Well, first we need a start date, so let's just say date start is to patient program dot get date enrolled. This is going to act as the start date, and then we have date end patient program get date completed. Okay, and this will be null while the program is still open. If the program hasn't ended, this is going to be null. And now we have a list of observations to collect, and these are related to this program. So I'm going to say program obs, new array list, and for every observation we have in all obs, we are going to put only those observations which are related to this program. So I'm going to say programs dot add obs under certain condition if true. Now what is this is true? If true, see, we have multiple ways of identifying whether an observation lies within a program or not. Now, one of sort of a straightforward ways is to look for patient program, right? And remember, this is a nested loop, so we do have the current patient program, and then get an encounter, get respective encounter. Let me actually hunt for the exact variable which tells the related encounter against a patient's program. So I'm going to populate something, concept name, where name like, let's see, yeah. So what we are saying is we have a concept name called MDI-TB program and a dots program, and we create an encounter. Against that encounter we store an observation, and that observation has a concept called dots program or MDI-TB program. So we have to trace back that observation, and then from that observation we are going to pick an encounter, and for that encounter we are going to fetch all the observations respectively. This is too much processing. First of all, this is too much processing. Secondly, it's making our call like hierarchical. So it sounds like it's this might be the right way to identify the set of observations. It is actually quite inefficient and may have some bugs, because there's no guarantee that this data is perfect throughout the system. So what I'm going to do is something else. This appears like as if it's a sort of a loose criteria, but it is more stable, more accurate, and more efficient. Will execute faster as well. What we are going to see is we are going to identify the program's date window. So by date window I mean we will see if the observation is within the window of the program itself. Now we have programs start date, we have programs end date, and we have observations own date. So if the date is within that particular range, then yes, we are going to add it, otherwise don't. So we are going to, let's actually create a helper function. Let's create a helper function here. Private boolean is within program window. I'm just leaving it here for convenience. This has to be moved to respective utility, respective class where this function should exist ideally. So for now I'm just gonna leave it here. So date, and I have whatever target date is, then we have start, and then we have end. There's going to be 3 dates. This isn't really a difficult thing to do, but because of the null checks we have to create a new one. If date is null, then of course return false, and then if the start is not null and date is before start, then false. If end is not null and then date is after, and then return false. If none of that happens, then return true. Right? This could be inline, I think. Yeah. So I'm going to now call this one over here and pass on the obs date. Be very careful. We are not interested in get value date, we are interested in get obs date time. This is quite important thing to note here. The get value date is the value stored within that observation, not the time when the observation was recorded, and then the rest is fine. If it is within it, then we are going to add this observation in the program obs. So for this program, we now have collected all the program observations. We're going to put it there. Over here. Why is this complaining exactly? Return set. This will also be a set. Patient identifiers. Okay, cool. Next, we have actually in the program summary, let me also keep add a new summary and patient program, then we have program ops, and then we have program lab tests, right? These are the 3 things I need. In each summary we have patient program, observation, lab tests. So let's talk about lab tests. Why do you have a problem with me? Okay, no worries. I'll fix this. Okay, now for the lab tests. How am I going to separate out the lab tests? Again, we okay. Observations, and this is the last one we have to do. We can create another similarly lab test, just like what we did with obs. I'm going to create a program lab tests list, and then for all the tests, once again I'm going to check the date window. If the lab test is within that window, then yes, add it, otherwise don't. So again, is within program window lab test dot get date. Okay, here's the catch. Here is a catch. I'm going to put in start and end here. Just complete it first. But this date is not going to come from lab test. This is actually going to come from the respective order. So what do I mean by that? Whenever a lab test is conducted, there is going to be an order created, and first of all there's an encounter, and an order is attached with that encounter, and it's actually the encounter's date which we are looking for. That date should fall within this start and end window, otherwise not. So what I'm going to do is it's going to be lab test dot get order dot get encounter dot get encounter date time. However, there is going to be a null check guard. I'm going to say if lab test dot get order is not equal to null, then do this. Let's rename it target date. There's a reason for that. So the order must not be null, and then the encounter within that order must also not be null. Lab test dot get order dot get encounter. There has to be an order associated. This will, like in 99.99% cases, this will be there, but encounter may not be there. Depends on, we have actually done a bunch of migrations, so these are all extra guards we are having to put around our code. Otherwise, if it was just a plain implementation, we wouldn't have to put in all these extra null checks. But anyway, just to make sure that our code doesn't crash, we are going to set a target date. If this doesn't happen, what then? Then the target date is going to be, then in worst case scenario, we are going to pick the lab test date created. So now we have a more stable way of identifying the tests which fall within the dates of this program itself, right? Now there's a caveat, and this is an operational problem not related to the flow implemented here. The operational problem is, what if both DOTS and MDR-DB programs are running side by side? Now to answer with that, they should not be running side by side. If a patient is already enrolled into DOTS program, then the patient should not be part of the MDR-DB program. Before closing the DOTS program, he should not be enrolled into MDR-DB, and vice versa. There should not be any patient enrolled in multiple MDR-DB programs. So that's the problem with the data itself. That's an operational problem, not with the code. However, if tomorrow you add another program, say comorbid conditions, or something like blood sugar for diabetes, that is going to be a separate program that will come in summary, but you will have to make a specific change in the code itself to pull those. See, we have picked common test type. This is for TB only. These tests are only related to TB. But what we are saying is, to have another program, we will have another common test type for that program. So for diabetes, thus the cluster of tests which will be performed is going to be separate from the TB tests. But anyway, this is about the business rule implementation, the business logic. This has nothing to do with our current flow. So this is redundant null. We have this implementation of get patient summary, which is going to return a patient summary object, right? And this patient summary object will then be returned over here. So right now I am going to jump into the OMOD, and I'm going to say context dot get service dot it's mdrtb service dot class dot get patient summary, and I'm going to pass the patient object. This is going to return me what? This is gonna give me a patient summary. But what I want in return to be returned is not patient summary object, it's simple patient summary data object. So I am going to pass in this variable, this object, patient summary object, inside it, and in the simple patient summary data, I'm going to close this one. In this class, I will tell it so we have patient identifier, we have so we no longer have patient programs. So first of all, let's just do this patient summary, and then so patient summary does not return patient programs any longer. It filters out all the variables that are required within this patient program and then populates those only. So I'm going to return another, I'll have to add another yet another DTO which will represent the patient program summary, not the patient summary object, the program summary object. So this will change to simple patient program summary, not the patient program object. So let me go ahead and create another DTO, and this one I'm going to call simple patient program summary. Okay, and now we have another DTO to create. So let's go ahead and do the obvious stuff. Extends base OpenMRS data, and it's going to ask for IDs, blah blah blah. Yeah, go ahead. I will also be creating another serial UID, and in the patient program summary I'm going to need what? So the program summary, let me pull that object to get some sense of what we need. Okay, so this object contains patient program and observations, and like a start and end date. We also have a treatment outcome. This is gonna go over here, and then we have observations, right? Observations in lab tests. So let's go ahead and create a bunch of variables. Private, and this is going to hold patient UUID first of all, then private string program name, right, and then private string patient program UUID. This UUID is going to be, okay, I'll explain it later. And you don't need to touch these, there's no ID. It just, this is required by the base OpenMRS data. We're not going to use integer IDs as the standards of REST module go. And we are gonna have a date for start date, end date. We have, of course, we have treatment outcome. And then we have a private list of observations. Sure, go ahead. And then list of lab tests. Okay, so that's all we need. And let's go ahead and create getters and setters for all of them. All right, so this is done, and we can also go ahead and create constructor that contains these. Yeah, and I think that's pretty much all we need in this class. So this simple patient program summary is what is going to go over here. let's replace and exclude, replace uh, match keys, replace all, and we need to rename this one to something else. Anyway, that's not really important. The most important part is over here, how to convert a patient summary object into the simple patient summary data object. But before I go ahead and do this, there's a very important aspect which we missed, and that is unit testing.